Space is vast and filled with weird and wonderful things. Space is an almost perfect vacuum, nearly void of matter and with extremely low pressure. In space, sound doesn't carry because there are molecules close enough together to transmit sound between them. Not quite empty, bits of gas, dust, and other matters floats around emptier areas of the universe, while more crowded region can host planets, stars, and galaxies. From our earthbound perspective, outer space is most often thought to begin about 62 miles, that is 100 kilometers above sea level, at what it is known as the Kármán line. This is an imaginary boundary at an altitude where there is no appreciable air to breathe or scatter light. Here are some of the most mind blowing facts about space and astronomy. Do you know? The moon is lemon shaped. Despite its appearance in the night sky, our natural satellite is nowhere near round. In fact, the moon is shaped like a lemon with flattened poles and bulges on both the near and far side around its equator. This strange shape is thought to have been created during interaction with Earth soon after it's formed. You could survive for a couple of minutes in a leaky spacesuit. Although it would definitely be unpleasant, you could survive for a couple of minutes. After around 10 seconds, you would lose consciousness. The lower pressure of the vacuum would cause your blood to boil along with the body fluids. But this boiling alone would not be fatal due to the pressure maintained by your body vessels themselves. Gas bubbles would form in our body fluids, causing your body to swell up and bloat. The low humidity of space would cause you to cool down rapidly and your eyes may freeze over. Within 1-2 minutes, the lack of oxygen would be deadly. The stress of the situation may make the symptoms worse. You would become oxygen deprived more quickly. A rapid decompression would cause damage to your lung, eardrums, and sinuses, along with the bruising and bleeding from soft tissues. 1 tablespoon of neutron star weighs the same as the human population. An artistic impression of a rotating neutron star known as pulsar. A neutron star's density is mind-blowing. Almost entirely of neutrons packed together in a tiny radius. Just a teaspoon of this material would weigh over 1 trillion kilograms more than the weight of an entire human population. To make something as dense as a neutron star, the whole of humanity would need to be crammed into a space the size of a sugar cube. Gamma ray burst can release more energy in 10 seconds than our sun will in for the entire life. An artistic impression of gamma ray burst has been credited by ESA Humble M. Cormesser. Nothing in the universe reveals the power unleashed during a gamma ray burst. A brief but incredible intense flash of high energy radiation. There are many types of GRB. Some are thought to form when a massive star implodes, others when 2 neutron stars merge together. There are stars we will never able to see. Twinkling stars are an anathema to astronomers, as they are the sure sign of poor seeing. Even since the Big Bang, most objects in space have been moving away from one another. In fact, the expansion of the universe is actually accelerating. As regions of space are whistling, away from one another at even increasing rate, the first population of the star to form in the universe are now too far away from us to ever hope of spying them, even using the best present or future telescope. Hope it is not lost. We can attempt to spot them indirectly via the energetic burst of radiation they emit at the end of their lives. Black holes have theoretical opposites known as white holes. Black holes are known for their voracious apparatus. Their influence is so strong that even light can't escape from their gravity. But they have a theoretical converse, white holes. They are effectively the opposite of their dark relatives, spitting out lights and matters instead of trapping them. So far, they are purely hypothetical objects. Astronomers are contemplating how they could form in reality. In Jupiter's magnetic field were visible, it would appear bigger than the Moon. The region of space in which a Mars magnetic field dominates is known as magnetosphere. These regions surround planets, pulsars, and even our galaxy. The planets in our solar system have magnetospheres that interact with and are shaped by the charged particle in the wind streaming from our Sun. The largest magnetosphere is our solar system surrounds Jupiter. Jupiter rotates very fast and has a very strong magnetic field, and its magnetosphere is filled with plasma from its volcanary activity moon. This feature, coupled with the fact that the solar wind is lower and less dense at Jupiter than at Earth, led to a very sizable Jovian magnetosphere. It is easily big enough to contain the body of the size of our Sun, and if visible, would be larger than the Moon in our night sky. Quite an achievement considering that it is 1,500 times farther away. Neptune has only completed one orbit around the Sun since its discovery. Neptune takes a whopping of 165 years to complete one full orbit around the Sun. Since it was discovered in 1846, Neptune only recently finished its full post-discovery orbit in 2011. Demoted planet Pluto has yet to match this. It is not even close to completing one full 248 years orbit since its discovery in 1930. Planets can wander through space without a parent star. Not all planets form and stay around these stars. Astronomers estimate that there could be more than 200 billions of the floating free and drifting through our gallery. These rock planets were thought to have been kicked out of their home system, while this is turned from some other planets may have formed completely independent of ascension disk. The Sun loses a billion kilos per second. Particles in the Sun's uppermost atmosphere are so hot and energetic that they speed out into space as part of the solar wind. Our star sheds 1.3 trillion particles every second. This equates to roughly 1 billion kilometers of distance and kilogram of matter per second, or one Earth every 185 million years. Please subscribe to find more and feed your brain more.